Let's discuss today about ad metrics aggregation and its system design. Before we even start jumping into the conversation around what to design here, first let's understand that what do we mean here by ad metrics aggregation. Let's begin with a story. Here we can see different advertisers, Nike, Adidas, Puma, and here we are the publisher. To again emphasize publisher, why I have drawn such box is because it's a website. So this is our website window, and let's say I am a publisher who is giving space for ads over here. Basically, I want to earn some money by providing space in my website where advertisers can put ad placements. How does this work? Actually, there will be a broker in between. Now it can be Google, Meta, all the different ad services. What happens? Advertiser places, they go via the concept of campaign, and in the campaign there will be groups, and under the group there will be ad topics. Now via this they will put some, let's say they do a budget of $2,000, every other company or advertiser. What they will do is, for every topic that they will put some under the budget is determined by the campaign. For the topic, there will be a kind of competition happening between all the different advertisers for this particular topic. Now we are also, so there are two parties, advertiser and publisher. This both come under the Google ad service, AdSense. So basically, now that I will use my other color pen, there is a middle party in between. Advertisers are putting their money over here, dollars. So basically they will place something like $22,000 per month. How do we earn? We have already leased our space. So in the HTML, using the SDK provided by Google, we will introduce some snippets in our HTML code. These will be acting as placeholders. What happens when our website, a user comes and views, like somebody came over here and started viewing the website, automatically we reach out to the Google ad server. I'm not going to the design right now, but let's assume this is the Google ad server. It has to, so our SDK communicates with the server and asks for ad IDs in the real time. Ad ID will then also reach out to the CDN to exactly fetch those ads using the ad ID. Now once a user clicks on any of the ads, that is converted into a cost per click, CPC count. If it is a successful click, so basically if the ad is clicked, then it will be redirected to the advertiser's website or whatever is the redirection, using a 301 redirect. That is not a big deal. Big deal is the moment an ad is clicked, some part of the money, like which was put under the budget for this advertiser, that will be cut off from their bill. So for example, here ad is charging around let's say $5 per click. So from $5, if I am sure, Google keeps a cut of 32% and rest 68% I will earn. So this is my earning. So you see here, this is a contractual nature where advertisers are willing to pay money and we want to earn money. That means we want to be sure that every click that happens on our portal, that should be accounted for, and advertisers want to make sure that they only pay for genuine user clicks, no bot, nothing of that sort, and no extra clicks. I am knowingly saying these terms because they matter a lot. If let's say our clicks are if our clicks are getting collected and anybody manipulates, like any bot comes and does some extra clicks, they should also not be counted. Also, any click that has happened on my site, that should be exactly counted. Let's say 5 clicks happened throughout the day. I want the money for all the 5 clicks because those are clicks per count that have got converted. And advertiser does not want to pay greater than or like any greater than 5 clicks. So we have to keep the financial accounting, that is the number of clicks. This is the important segment over here, and that is what we mean by ad metrics aggregation, the number of clicks, because this is the money maker. And then obviously advertiser, they have a view to their own dashboard, and the publisher, they have a view to their own dashboard, which we will be seeing in the next steps. Here we get to see the different metrics. So this is our publisher, that is, for example, me, I have my website hosted and I am providing my ad click spaces. So something like estimated earnings, page impressions, clicks, page CTR. These are various terminologies that are used in ad world, because by this I can understand, because I have a earning potential in mind. So accordingly I will see that, okay, these are the pages, they earn this much, and these are the earnings per particular page. Then I will optimize that, what is the entry point and all. So as a publisher in Google AdSense, this is what I see it. And what about the advertiser? So advertiser will see how much total spend has happened, what are the impressions, what are the overall clicks they have received, average click per count, CPC, then conversions, and overall clicks versus conversion, as well as particular ad groups. So that way they can optimize their ads as well, and positioning, like what exactly the ad talks about and how much cost they have incurred per ad, all these things. Having seen both the dashboards of publisher and advertiser, now let's try to understand the requirements. So first and foremost, we have to accept and store all the ad clicks. Next, each click is counted exactly once. No duplicacy, no misses. Very important. If I am duplicating my clicks, then the advertiser has to pay more. If there are misses, then the publisher has to earn less. We don't want both of them. Aggregate click by multiple dimensions. And by dimensions, we mean a lot of dimensions, because they could try to look by ad, by campaign, by advertiser. Now, most of them are from a advertiser's perspective. Then publisher. From publisher point of view, we can see CTC, page metrics, all these things. So every person needs something, and there are a lot of things that needs to be aggregated. So these are the multiple dimensions. This will also come handy in our later design. Query aggregated data with flexible filtering and time ranges. This is when in the dashboard, as I had shown earlier, they will be doing there will be different filters. They will be selecting from that, and filtering will happen. Then also the bar graph that we generated, these can be selected using the drop down of date range, and this graph will change. And then obviously real-time dashboard. By real-time dashboard, we mean staleness in data of, let's say, 1 to 2 minutes. That is what is perceived as a real-time dashboard. We kind of consider, like, we can increase it to 5 minutes, but if we are bringing something to 5 minutes, we can bring it down to 2 minutes as well. So I'll keep it in within this range. These form all our functional requirements. Functional requirements, because without this, the business will not stand out. And again, to give a final nail in the coffin, the flow here is advertiser wants clicks and publisher wants to get paid. That's it. So this is like a marketplace which is doing the matching. In terms of bidding, it's like, say this is Nike. I'm just repeating myself, but making sure that everyone understands. And Adidas, it has done a bid of $2 per ad impression. This has done a $3 ad per impression, and it has done a $1 per ad impression. Now Nike does not know how much Puma and Adidas has done. It will put its own bid, and all the bids will be compared. The highest bidder will win that auction. This happens every time. So whenever publisher asks that, okay, these are my empty slots, they need to be filled, like for every user session, it will be shown dynamically, and the server has to return back with the impression. Impression is nothing but running a auction system, checking that dynamically which is the highest auctioneer right now, bidder right now, and that bidder will win, and their ad will be placed here. So that's what every ad position is an impression, and each impression will have a different ad. So like, it can be same ad, different ad, depends on what is the campaign budget of the advertiser. So having said that, now let's jump into the system design. Think about it. We have two things over here. One, the user, and the other is the ad metric, Google AdSense here. The user is equivalent to the browser. Someone comes in the browser, the user first requests to the AdSense that, hey, these are my empty slots, I need some ID over here. It will run its own auction, and whoever is the highest bidder, those ad IDs will come over here as a response. Now the user will do clicks, like they do click. One click is more than enough. Then we have our load balancer, via which, or you can say API gateway / load balancer. Via this, the request, or that is the click, comes. At the same time, whatever has happened over here at the ad server, the impression, that also needs to be sent. To give a very brief idea of what the content of an impression would look like, something like the impression ID, campaign, advertiser, bid ID, user segment, country, and the timestamp. So this will be an impression. And regarding the click, the data would be something like impression ID, basically which impression won the bid, click ID, and the timestamp, basically when this click was collected. So obviously this is one partial data and this is another partial data, both connected over the impression ID. Now that we know that what are the two different data objects, impression ID and the click object, what after this? Then we have to collect it into a database, and then there will be a reader, basically two different readers, one is the advertiser and one is the publisher, and they query the database, obviously via the read path. So basically this will also be a read server or read service that will cater to it. So what is so great about this entire system design? Why do we even want to think about it? This is the special case, or like there are in general cases where the design itself is not that complicated. It's more about the kind of soft data or the internal non-functional requirements that we want, because this is internally a very write heavy system. We haven't actually looked at the actual metrics or the numbers. This system kind of needs to handle the pressure of. To give a very brief view of what we are handling right now, because clicks are something which keep happening so often, Google itself reports that it ingests around 10 billion clicks per day. If we were to consider one day as roughly 10 to the power seconds, then it is 10 into 9 by 10 power 5. It's like 10 to the power 5 writes per second, WPS. This kind of load, where reads are roughly only like somewhere around 10,000 reads per second, not even 10,000, I would say 1,000 reads per second. How often are people coming and looking at the dashboard? It's a very write oriented, where WPS is much greater than RPS. In such kind of a database, there are multiple things. Should we go with a SQL database? Should we go with a NoSQL database? Should we go, in this also, should we go with a row format, or which we also say, not also say, but more like a OLTP database, transactional in nature, or should we go with an OLAP database? We also have to keep the data in mind. Obviously, we have understood that it is a write-heavy system. We cannot go with a SQL where every commit that is happening into the database is like a transaction and locks are coming. If the system is full-time involved with locking the system, then writes will keep choking. Even if we put buffers behind it or something to absorb the large rush, we cannot. So what's next? What is so special about this data actually? First of all, these are click data. Click data is only append only in nature. This is also something we have to keep in mind. That means if there is some data, let's say I put in my table, these are my different columns, and I just keep appending, I will never go back to any row and I will never change any data. This is a huge relief for me in terms of what I want to do with this data. Generally, when a data is append only, the only thing that I want out of this data are metrics. I do not want to do any updates on this data. If for this reason, I am anyhow able to change my access pattern of the data. That is, say, instead of storing our data, as I said earlier here, if we store it something like this, these are my different columns, call 1, call 2, call 3, and I keep storing. So basically each entry here, it's basically same thing, but the way this is stored is completely different. Here, if I say treat it as R1, R2, in the disk, R1 with all its data and then R2 with all its data, everything is stored sequentially. I mean, I'm not going to the complexity that ultimately this is a B tree in action via linked pointer, linked list pointers, or like how we treat the pointer concept, but more towards each of them are different files and all my data are getting appended here. Obviously, if I take ID 0, like 0th index of each of these column entries, like each of these file entries, they are equivalent to one record entry over here. Then this is what is the feature or nature of OLAP database. I have a small slide. This visual representation will help you guys. So here we can see that I have my row store format and column store format. Obviously, there are many such examples like ClickHouse, Apache Druid, etc. Now, the main thing is different. For example, here also we are storing timestamp, but timestamp, add ID, country, click, how many times this ad has been clicked, everything. But these are row format, and here they are column format. As simple as one whole row sits together, and here we can fetch. So when we are doing the select star query, or let's say select and all the column names, what we do is basically fetch the entire row and then selectively filter. Or even if we have to do any operations over it, that is one, we fetch one particular row or particular rows where we are matching some conditions, and when we do the operations. But in column, we just have to do an aggregation. Like let's say I want to just aggregate the total number of clicks. Or the query engine just has to go to the click column and do a full query, that is a summing aggregation, whatever operator we are applying. That is the powerful feature of a column store or the OLAP database. Now, one more example here. When I'm doing sum of clicked, where country is US, now we only have to touch two columns. We just want to touch this click column and the country column. And that is where we are done. When we are doing a row store, OLTP databases, it anyways is going to touch all the columns, fetch multiple columns. And if you remember, in our requirements, we have already told that we will be doing multiple metrics into our dashboard. So these multiple metrics means there will be n number of columns, and that too when writes are so heavy and there are so many columns, it's a very huge deal. So we need some storage in memory as well. So this is when row store drags across all 4 columns of every row to answer it. Column store reads just country plus click and ignores the rest. Only 40 columns into billions of rows. That's the whole game. Next, if we go, there is also the memory optimization which comes in OLAP databases. For example, when we have a country column, then if we go and show that there are multiple countries, how many countries can there be? The chances are, first of all, there will be limited set of countries, that number is capped. The other thing is the proximity. Like most of the times, similar kind of data comes much more in succession. Then you can run optimization in storage as well. So You can do run length encoding. You can write it somewhere as US into 3, IN into 2, and US into 3. In your file, you will not store as it is, rather than you will store it in this way. Same goes for dictionary format. You will store US and India in this format. So basically now you know, combining these, you know that there are only two countries encoded as US index is 4 and India index is 5. That's it. Next thing is delta, the timestamps. Because the timestamps, if you go back, the timestamps are also in incremental nature in general. So you can take on base timestamp and just keep deltas with it, and that way you are able to store, instead of 100 GB interleaved type data in column, you can compress it very huge. This is a very huge reduction in space. Now that we have discussed that the kind of database we will be storing, what next? Again, let me just store the right path over here. And as I told, there is the Google AdSense, which has done the bidding and auction. It has communicated and provided you with the ID, the bid ID. Once the bid ID reaches here, the click happens over here. This is the click metrics, and this is the impression metrics. So drawing it over here, I'm getting my impression data and I'm getting my click data. Now, as I said, these keep happening each day throughout the whole year. There is no stop in it. I have to kind of do a combination of these two individual streams of data. The word stream is very important here. And then push it into my OLAP database. In this case, I will name it as ClickHouse. How can I do it? Or first of all, if I forget, there is a joining also. Let's for some time forget that this entire joining path exists. If I only were to take the click column itself, if I copy it from here and paste it over here. So if you remember, I had my impression ID, click ID, and timestamp. So somebody, when they are querying their dashboard, they want to see the number of clicks. There is a reason we went with OLAP database, obviously because it helps in doing aggregation, but we want aggregation when this is stored into the database itself. Like for so-and-so ad, these many number of clicks has happened. We kind of want this kind of an entry first to begin with. Obviously, this data is also going into the OLAP DB, but some aggregated data also should be going into the OLAP DB. How will this aggregation happen? For that, we need a concept of streaming and stream processors. That is where today Flink kind of architecture exists. So this is Apache Flink. Obviously, drawing a rectangle does not mean I have drawn the entire thing. But what Flink says is, it follows the concept of source and sink. And then there are operations in between. It's saying like, after every operation happens, the output is also a stream. So basically, I could have done a source to a stream, source to a sink using my stream. Stream 1 went and stream 2 came out. Both are streams. But if I do operators, which we can define using the Flink SDK, then those operators can perform function over the sink, over the stream, and it can manipulate the stream data into what we want, and finally the output contains exactly what we need. Now, what more does Flink provide out of the box, which we really need? One, the sequence in which we are receiving clicks, because there will be network lag, because client 1, client 2, different clients sending data, there is the gateway which will be receiving, and maybe it can do a delay, and also there might be a thread management issue. So we will be receiving clicks out of order. Flink does ordering guarantee to begin with. Next, it is very durable. It does state management. So the state, when in the Flink, one stream reaches and operator OP1 works over it, then it will create a checkpoint. That is, it will remember in its state that this is the particular operation I did. And to be honest here, there will be a consumer. Mostly it is done using Kafka, but we'll come to this topic. Kafka works by the concept of offset. So what it will store is offset of its own consumption, and the particular operator it will store as a checkpoint. And this creates durability because Flink is actually a cluster of different task workers. I'll just give a very brief overview of the internal structure of Flink, mainly because this is not actually the main component. It's more like an introduction that these things are working for the sake of the design of this entire system. The system is very lightweight, but the powerful components in it are what makes this system a discussion worthy topic. So having said that, once the checkpointing is done, there are other scenarios what also Flink helps in. For example, I got an event at 10:00:01, 10:00:02, similarly 03, 04, 05. This is not directly related to click, but it is more related to the window. There are different windows we can take. This is called sliding window. For every 2 seconds, I want some kind of aggregation. This is called windowing. Obviously, spelling wrong, there should be an N. The other thing is watermark. The combination of window and watermark is very helpful. Watermark is, let's say I want an aggregation over 3 seconds, but my event 3 did not really come at event 3. So there are two things. One is the event time and one is the processing time. event time is exactly when this event came. Event snapshot is 003. But processing time is when I in the Flink, like me, Flink as a system, received it. I received it at 10:005. My window, because for me when I'm saying 3, my processing time has already begun and my ticker went till 0, 1, 2, 3. I waited for 3 seconds and I did not get. In a stream processing system, this is very harmful because that means this data is completely rejected. And in case you remember, we cannot reject any data. No duplication, no miss. Here, data miss did not happen just because our click did not land. It's actually because we were thinking our system is not able to handle. This is again where Flink shows its power. Flink says that I will go with the concept of watermark. This watermark, what I will do is, in watermark, I as a user will configure, let's say that I can give a lag of 5 seconds. Now, when I give a lag of 5 seconds, that means even though my processing time has passed by 3, I will still wait for more 5 seconds, and that I will consider. So when my 10 processing time checks as 10:005, and then I see that I have received my 10:003, the depth of it is 2. With respect to my watermark, which I had put a 5, with respect to 0, I have enough margin to capture it. So it will wait till then. Obviously, after the watermark, no more data is entertained. We will discuss about that scenario as well later. But till then, watermark gives me a flexibility that event which is coming later, that can also be processed. And the final part is the operators that we are applying. So by operators, we can put one operator as deduplication internally. So think, if I am getting streams, and by deduplication we mean, let's say by any reason, an event happened over here, one click, which is click ID 1, and it went to my server. It tried to reach to my server, but it could not. There was some network issue. And then another click ID happened because ID 1 was not able to reach. It again used the same ID to represent the same click and send it later. But eventually this packet also landed, this packet also landed. So there are 2 click IDs, same click IDs, which happened. Or otherwise, there is a bot which is firing clicks very rapidly. Like I could do it. I can abuse the system. So then also ID generates, ID is not partitioned here. Basically ID is not distinguished because it's done such a high rate. So all these clicks start landing over here. I only want to treat one unique click ID as one click. That is where we need a deduplicating operator. The other part is aggregations. As I said, we want to aggregate over ad ID, we want to aggregate over campaign ID, we want to aggregate over country. Like the aggregations can keep widening. Again, our custom operators in the Flink that we write using the SDK, that will be implementing it. Finally, why Flink? Why not any other? Because first of all, Flink was built after Spark. Just to give a brief history of how the entire advancement happened. Earlier, what used to happen, there was this concept that I receive some amount of data, then I store it into my DB, then my Spark wakes up, it collects like certain set of data, like last 1 hour worth of data, and then do processing. This is called batch processing. And this is what Spark does. After Flink came into picture, and both are actually by Apache, the main reason was Apache built Flink was to treat that these are stream data. Streaming data should have the power that I take any point in time and I can start aggregation over it or any operator function over it. I should not be doing a batch. What is the problem with batch? The latency that comes inherently. That means, let's say a recommendation engine is working, which runs on the metrics collected. Let's say I am watching I'm scrolling YouTube. I keep watching different videos at different points of time. Now, all these data are getting collected into my metric system. If let's say I do a batching, this is my database right now. If I were to do a batching, then it will happen at regular intervals. Say T is the regular interval. In this case, I take as 10 minutes. After I have watched the event, I have watched anything and those events got recorded. The next video that will come will be based on stale batch data, not on the current batch data. That is the problem, entire problem with batch processing. There's a paradigm which needs batch processing, but then there are these paradigms where, for example, live dashboard, live recommendation engine, the word live where comes into picture. We need streaming. So again, clearing this clutter. This is on a very high level what Flink is. As I said, I'll just introduce very loosely and briefly what Flink looks like. So this is my Flink cluster. And here there will be one job manager, JM. There will be different workers. These are called task manager. I'll say them as TM. TM stands for task manager here. Their data streams, which come over here via the client, they will be passed around to the different task managers or within the task managers. Task managers are nothing but worker servers. So there will be like, what we have to do, this is our server basically. We have to spin up different, allocate basically individual nodes which act as the worker nodes. Job manager's task is, actually it will have a dispatcher. It will understand, okay, which exact task a worker is free. It will dispatch the task to it. It will manage the state of the task. And then it will record that observation. And finally, there is a job coordinator So it will create a DAG graph, it will try to understand that in which state we are, and accordingly it will manage the entire event. So this is what keeps happening. This is basically a distributed system of task management, and that is what Apache Flink is overall internally. Coming forward out of it, we have done two things right now. We know that we are storing it into our OLAP DB. We know that we are passing the entire stream through Flink. And now that you guys know the architecture of Flink, I will draw operator over here. And two things are coming here. One is the click, one is the impression. Then the impression and click are getting aggregated, as well as different components of click are also getting aggregated. And from Flink, we will pass it to OLAP DB. The main benefit of this is that when we have to do a read query to the OLAP DB, obviously via load balancer, this is like not a main concern right now. We will just directly do a query which already has those columns aggregated, and we will just have to do a get request with the query params, like whatever parameters we have to pass, and we will directly get it from the OLAP. And if needed, we will introduce a cache over here. If the queries are very common in nature, then we will do a caching and we will read it in our, this is our basically client or reader in this case, the dashboard basically. But now we have to start understanding that these components are not enough. The main problem is the number again itself, 10 to the power 5 clicks or basically writes per second. The problem with this kind of load is, what if Flink dies in between, like dead? All these clicks, they will start losing out. We have our server which is receiving those clicks, and this has to spin up horizontally to manage this amount of load. And obviously on a Black Friday, the load will go 3x, so it will be somewhere in 3 into 10.5 range. What then? We have to do a shock absorber here. The shock absorber's main quality should be durable, and at the same time, it should be disposable. Durability and disposability are two different aspects. Durable means if my Flink has dropped at certain point, it can again pull in this kind of data or replay the entire sequence of data to start working again. That is where durability comes into picture. Disposable means if needed, all these content can be disposed of. That is, if Flink wants, it can, let's say it has read these first 3 items and it has done the work. Now it wants 4th item. Then it is disposable enough as well. Means if crash happens, then it can reread these 3 datas. And if crash did not happen, things are going fine, then it wants next set of data. This is something a queue can do, and not any queue. Durable queues basically are either Kafka or Kinesis. Kinesis is nothing but it is AWS managed Kafka version, not Kafka generally, but taken inspiration from Kafka and completely managed by Kinesis. The terminology kind of will be different. But the main aspect of Kafka is it uses the concept of topics and brokers. Topics is again, the way Kafka handles topics is in a file, that too for dedicated consumer. It will have different offsets. So let's say I have C1 and I have C2, both reading to topic 1. So it will say my offset as OF1 and this as OF2. These are the 2 different offsets. This same task could have been done by an SQS or message queue also, if in case somebody thinks. Then the main problem is, if let's say there are 2 workers who are consuming an SQS and this message is over here, when worker 1 consumes the message, it will be basically equivalent to marking it invisible for some time. Worker 2 will not be able to view this message. That is, whoever gains entry to the topic first, it will be only able to work on it. And also, if you want worker 2 to actually work on it, then once from invisible state it becomes visible, it should not call the delete message. But ideally, the SQS is done where all these workers are identical and we just want to scale up the process. Kafka is not meant for this. Kafka means durable messages because the topics are actually in file storage format and multiple different kinds of consumers can consume it. Obviously, the diagram has become a bit messy. I will use my highlighter over here. So, as I said, different offsets will be used for different consumers. There is no race condition between who gets access because everyone is reading at their own capacity. Kafka is so durable that it also stores the offset of that last consumer, and it can provide back that information to the consumer as well, that what was the last offset they had read over there. And using this, our Flink will start reading from the last offset if there is any crash, or otherwise if the service is up, then it will start reading the other backlog data. So this stream will always keep working in a durable fashion. The other reason also that we are going with Kafka, and this is not a choice anymore, it's Kafka by its own nature it provides. One is the partitioning and other is the order guarantee. Order guarantee is interleaved with partition actually. So partition here, because I said file storage, so consider, let's say if I do a partition ID using click ID, then in my file for that particular topic, all those clicks, basically the topic here would be click ID or the event itself. I'm just saying click ID for example, it will go to one file, and that is how the partitioning will happen. And to read over here also, we are getting an ordering guarantee. That means message in one partition are read in the exact order they were written by offset, like strict FIFO is getting maintained. So this FIFO ordering is getting maintained. This is the exact ordering guarantee that we need here in terms of when multiple clicks of same type, like my example of ID is wrong, but if let's say it was add ID or impression ID, then it starts making sense. We start getting everything in that one partition, and most of the time our clicks that we are getting from here from the consumer, these all will follow timestamp sequence. We are trying to make life easier by keeping them arranged, not out of order, and we want to consume it in that order only. Obviously Flink will then make sure that it kind of arranges them as per the event time. Having said that, still we are missing one more thing. Let's say if I again redraw the entire sequence, I have introduced my Kafka, then I have introduced my Flink, and then I have introduced my OLAP. Here the impressions are coming, here the clicks are coming. But the problem is, we don't want duplicate entries to go inside. Obviously, the way I had explained earlier that Flink will be able to do it, Flink by its own virtue does not do deduplication. We have to actually introduce an operator which has to do the deduplication. This is also an interesting topic actually, worth the 2 or 3 minutes of topic coverage that I will be doing right now. So if let's say I have received my click ID, and that too, this is 1, and again for 1. Now I don't care what these data are, because obviously this is on the same impression ID. Basically if I remove click ID also, it's like impression ID. For the same impression, I cannot receive more than 1 click. It's not possible. How do I make sure that in such a rate where we are matching 10 per 5 writes per second, I'm able to ingest it and at the same time make sure that I'm not deduplicating and entering duplicate things into my OLAP database? What we will do is, we can go by the concept of Redis. How will Redis help us? If we go and do a set nx that is not exists, then the resource name, resource name comes over here. Let me just rewrite it. Set click underscore ID and then nx. Nx is basically not exists, and we then put an expiry, let's say of 1 day. 1 day is basically 24 hours. I mean 10 per 5, but exact number is 86,400 seconds. That means now in the Redis store, this particular click ID, if it does not exist, then only set it up, and this will, the TTL is of 1 entire day, 24 hours. Now let's say another entry comes, and this also has the same click ID, because the Flink operator, as I told you, like there are different operators, this operator will again ask to set. It will get a nil value out of it. Nil means already exists, that means it is a duplicate effort. But the problem is, all the writes, 10 power 5 writes, every data is going via Redis. Then do you think there are so many duplicate values? What are the chances? Almost 95%, or I would say 98% of the data of these are not duplicate. Unnecessarily, there will be 98% entries for one entire day sitting in Redis. That is a load on the cluster itself. Even though that not high, but still it's a very high load. So what do we do next? If there was a way so that I can filter that this is really duplicate, if yes, then I pass it into my Redis, and if it is not, then directly into my DB. If I am able to do this distinction, if it is yes, then also why to do in Redis until it is like a maybe. Is it duplicate or not? If possibility, then only pass to Redis, then our life is easy. And this should click us something called Bloom filter. Bloom filter is pretty interesting. I will show this using my slides. Now just to give a very brief idea first before moving to the slides, think of it in this way. I have my parameter tunable k. It's basically like a hash function. That means I have some input I, which I do #1 hash. If I put k is equal to 2, then I pass it through 2 hash functions and I get some output like O1 and O2. I have a bit set. Basically it says, it generally is mapped to this entire range. Same goes for this. So it will, let's say, give 0, it will give 2. Then I will toggle, everything is first kept 0. Then I toggle index 0 to 1 and I toggle index 2 to 1. This is same thing. And if I change it to 3, then there will be other hash functions like multiple hashes. The point is, the more hashes we introduce, the lesser chances are of collision, and every item that we push into the Bloom filter, all will be unique. The chances of collision are less, but not 0. Means, if via my Bloom filter, I pass object 1 and object 2, and I get, because what I check or what Bloom filter checks is, the particular index, is it set or not set? If there is a set, that means maybe. If not set, and not set means if let's say I set my value as k equals to 2, then both the values, like both the bits, so let's say I put in item 2 here, and h1 of i2 is 1, h2 of i2 is 3, then I will go and put this as 1 and this as 1. Since both are unset, so totally it is not set. That's the output that will come. So that means it's surely not present. But if it is set, just because any of the set bits is set, then it is a maybe. And that is what I was trying to say. Let's go and switch over to slides to understand better. So here you guys can see I've already designed the Bloom filter. Now let's say we are trying to introduce click A. h1 of click A is 3 and h2 of click A is 9. So we are setting bit 3 and 9. Now I want to do the same with B, and it is like 6 and 12 are the output. We set those indices. So this is also part of the Bloom filter. Now once we are doing query over click A, which is a duplicate. Why? Because both 3 and 9 are set. That means when a repeated query is coming, then obviously it's very easy to detect. But query C, which is click C, which is a new click actually, it's 1 and 9, where 9 was already set. That means we are not able to differentiate, and it is a maybe then. Then we will go, so one probe bit is 0, impossible to have been inserted, no false negatives. So skip Redis and go straight to DB. But if in click D, if we are getting a probe bit as 3 and 12, which was already set previously, that was set by A and B, Bloom will say that it's a maybe. But for us, D was new. Then we have to pass it through Redis using the set with a not exists, and that is where we are able to distinguish between a maybe and for sure not exists. Now coming back to our drawing board again, we have actually covered all the important and critical parts of this entire design. Just to replay a bit, and this time I'll be much cleaner. This is our Kafka. From here, ingestion will happen over the Flink. One of the prior important things is now we have introduced the concept of Redis. So basically Bloom filter is a software algorithm. So one of the operators, like the initial operator or one of the operators in between, will be the Bloom filter. Once, like, it will be a conditional in terms of flowchart, Bloom, and if there is set, means set bit, then it has to be passed to Redis, and if not, then directly to ClickDB or the OLAP database. I mean, kind of think I'm short circuiting over here and then putting my DB. So if this is true, click set is true, and this is for the no path. So we will pass to Redis using our set resource ID not exists, and if exists, like expiry set as whatever TTL value is there. Simple. The other thing also why Flink will be used is to detect bots. Again, in case things are passed via deduplication effort and everything, still there are different patterns. Like in card industry also, Flink is very much used because there are different operators which are working on stream. It can identify patterns as well using complex algorithms, that is it really a fraudulent activity or is it really a abuser who is kind of trying to exploit the system. All these things are there. But finally, obviously I will do another, this is the impression stream. The last part remaining is what we have covered so far, that all the clicks that are coming, right, around 10^5 writes per second, they are not getting lost because Kafka is absorbing it. That too, we are partitioning it by the necessary resource ID. Here in this case, click ID can be one of the top candidates. Then from Kafka, we are consuming it into Flink. Flink is working. Flink also has a concept of snapshot and everything. And it is also doing a deduplication check effort over via Redis and Bloom filter, which we have discussed, and passing it to ClickHouse DB. But what if Flink dies here at this point? If Flink crashes, which happens at times, then the entire effort of deduplication is lost. Why? Because let's say now the deduplication is not in the stream data. It's because of when the Flink comes back up. So let's say Flink was processing and click 1 after duplication effort went into ClickHouse DB and Flink failed. It failed by the time it had to create its own internal memory, like the memory snapshot. And then Flink came up. It will again, because offset and, as I said, offset and other operators are together saved as a memory state, and this offset is not saved now. Then when Flink comes up, then again click 1 gets entered. So now there are two click 1s, click ID 1s, just because Flink became ephemeral for some time. It crashed and it came up again. Then what do we do? This problem, if we are able to solve, then the final nail in the coffin is done. The first approach that we can take is, once this entire stream is done, this I will say S1, where different components are there, we will do a separate reconciliation. So now from this, we will attach a Spark job. I'll provide multiple approaches. This is my Kafka. It has all the topics stored because it uses file storage system for the topics. We will replay the entire event on our Spark. We can do it here itself for 1 day basis. We run our manual Spark job and we reconcile the data with the ClickDB. This is one way. The other way is same. The stream came, we have the ClickDB, we take Spark, we put a worker over here which reads the DB, passes it to Spark, does a reconciliation, and then stores it in another DB. I mean, when I say another DB, it's the same DB but a different table, a reconcile table. These are like case 1 and case 2. There is not much difference. One is the source is the topic itself replayed. This is over a day basis, and otherwise we can do it over a week. Then obviously Kafka can store, but for the sake of not exceeding the storage capacity pressure on our Kafka work services, we will do it from our ClickDB itself. But the problem in case 2 is, for doing the entire replay, we need raw streams. Kafka has raw streams. ClickDB has aggregated streams. That means we also need a persistent storage over here, S3. There is something called paraquet format. So what we are doing is, we are mimicking the exact column-wide storage of an OLAP database, but we are storing it into S3 as raw events. Like here it will be aggregated, like in a polished format. The unpolished clicks as it is will be stored in the S3. Then from S3, we can take it into our Spark and replay the entire thing. So instead of taking it from the DB, which I had initially started with explaining you guys, but actually we will be taking it over here from the S3, the Spark job. And then we will be updating our DB over here, this reconciliation. This is not a problem. Actually, people do it in the industry, but it's completely based on the non-functional requirement being imposed on us. Say, I saw a graph of this format. After my reconciliation, my graph is something of this format. There is a delta change. Now, if my product requirement says that I don't want the delta to be very high, and I don't want a delta at all. In these two cases, I cannot consider a batch processing, at least from the user perspective. I will tell you what I mean by user perspective, because even though I will go with the case 3 here, there will be a batch processing, but not at least for the user side at dashboard. It is for me, as like if I'm Google or Meta, I will be doing that batch processing. So what we want is our Flink, when it has created this snapshot into Redis, like when it is approaching Redis, checking all the deduplication effort has been done, then there should be an entire transactional commit that needs to happen. So what we do is we introduce another Kafka. Now bear with me. This is K2, this is K1. Just to differentiate between Kafka, and this is Flink. We consume from this Kafka and we emit or we produce into another Kafka. What happens with this is, there's concept of transaction in Kafka. That means a producer, when introduces any event into Kafka, they can gives the concept of commit. Means I have produced my event into Kafka, but until I don't commit, it is invisible. So if my consumer is sitting over here and it wants to consume it, it will not see this any event in the topic log. There is no topic worth consuming because it has not been committed by my publisher. So what we are doing is, we are putting all of this, and by all of this I mean there are 3 things that the Flink is doing. Read the input topic, that is from K1, manage internal state, and then write to output topic. These 3 things are there. It will be done in a 2-phase commit. The entire thing, this will happen in phase 1. And once, obviously the entire thing is actually 2-phase commit, because this entire thing is 1 phase. Means I have read the input topic, manage my internal state once, and also written to output topic, but I haven't committed to it. Once I'm sure that all of this task is done, then finally I will go to my phase 2 and trigger and say, basically signal the Kafka that please commit this, and then we are done. So if I were to again repeat the entire thing, we have read the input topic, we have done all the necessary processing, and whatever state we have achieved, even with the deduplication effort, everything, then finally, forget this right now because this is part of its internal topic aggregation, or like the different aggregators that we have, and then we finally push it to Kafka. This entire thing is 1 phase. If we are sure, then we finally do a final commit into the Kafka. Now cases. One case is, if my Flink dies and I haven't committed, then this is lost because it's hidden and this never gets to know. The other is the happy case, that Flink has died but it has also committed. If it has committed, that means the entire thing is actually in sync. But if it died and this was not present, then it has also lost its state as well. That's the problem. As I said, this phase and this phase have to go like it is a 2-phase commit. If phase 1 is done, then phase 2 will be done. But if phase 2 is not done, like phase 1 is not done, phase 2 will never happen. So that state is lost completely. It will restore and it will replay the Kafka topics. It will do the 2nd phase commit, and then it will reach the ClickDB. And this actually completes the entire thing. I will just draw a very clean diagram. Here we have the API gateway. We have our Kafka 1. Then we have our Flink F1. Then we have another Kafka K2. The Flink, one of its operators, it will reach out to Redis. There's Bloom filter internally, and this is our Redis. This Flink is also taking input from the ad server. Here our client is reaching. This is C1. And these are the different messages here. This is the entire stream internally. then it passes into Kafka 2. This is just to make it, I'll do it in a dotted format. This is for transactions. And then finally, there is our ClickTV OLAP database. Now there is the dashboard service. It will also reach out using load balancer to the query service, and it will read the aggregation from the ClickHouse database or any OLAP. The point is, once query service, there will be a Redis here for caching with a TTL. It will either reach to Redis, and if there is any miss, then it will be updated in the Redis. This is not big of a deal. The entire learning from here is that this is not very complicated design as we generally see in other system design concepts. Very simple, but it's the introduction of these kind of components: the Flink, Kafka for transaction, Kafka for ingestion, and then Bloom filter plus Redis, then the durability and double counting that we don't want to do. All of these. Now let's go back to our requirements just to see that everything is covered or not. We'll go one by one. Accept and store ad clicks, pretty easy. The rate that we do the ingestion, that is using Kafka as a buffer. Each click is counted exactly once, obviously. No duplication, we made multiple efforts for it, and no misses because again we are using Kafka. Aggregation of click is because of the use of OLAP database, and again Flink. These two together are helping us. Query aggregate data with flexible filtering and time range. This is very reader flexible. The main worker was OLAP, because in OLAP we were able to fit the data. That's why our query parameters will be working very nicely over the OLAP database. And real-time dashboard. This is again because of Flink in action. And the failure of Flink also we captured using another plus Kafka for the entire transaction. So multiple things repeating in entire across all of these topics. But then that is what leads to an ultimate business requirement, and there's direct guarantee because money is a sensitive thing. That's why we have to respect the no duplication and no miss effort over here, and that is why all of these things came into picture. But obviously Flink is also used in other places where we need live recommendation, and also we don't want to miss out on data. Then we go towards a Flink plus Kafka architecture as well. Obviously we're consuming from Kafka, so there are a lot of things that you guys must have learned today, or like if it is kind of revision again, then you might have revised. But yeah, in case you guys like the videos or there are any doubts, please comment, and then also like and share with your friends or any engineer who wants to discover these topics. And finally, please do subscribe to the channel. That gives me motivation to publish further videos. Obviously you guys must have seen that I made some changes to the quality of video today, playing around with the concept of showing slides. I might be enhancing my content further, and it takes a lot of effort, so please, looking forward to a lot of subscriptions.